Hello, can you hear me?
Yes, I can hear you.
Okay, so how are you?
Um, okay.
Okay, so we will complete our first day's online training session, and today
Yes,
is our second day. Okay,
yes.
okay,
This is our
okay,
second day.
okay. So now I simply share my screen.
Okay. Mm.
Okay, can you see my screen now?
Yes, I can see your screen.
Okay, okay. So hi and welcome to the 7 days online training session on Google Earth Engine for remote sensing analysis from beginners to advanced level. So this is the course will be taken the total 7 days, and I am course coordinator. And we already covered the first day, and today
Yes.
is our second day course content. Okay, so this is the
Mm.
full course content of the total 7 days. So we will try to complete all of the content within the 7 days. And today is the second day, and second day course content will be that today I will try to discuss about that how you can easily filtering and displaying the satellite images. So mainly Landsat and Sentinel, how you can easily filter the Landsat
Mm.
or Sentinel images from the Google Earth Engine platform and display the result on Google Earth Engine platform, and then how you can easily export these satellite images from the Google Earth Engine platform and work with the any software, just ArcMap QGIS. Okay, and
Mm.
then we also try to discuss about the different types of band combinations. Suppose false color band combination, true color band combination, and then export the satellite imagery. We also try to discuss about that how we can easily export the satellite imagery from the Google Earth Engine platform, and then how you can easily import, filter, reduce, and clip and the display data in Google Earth Engine platform. And then we also try to discuss about that how you can easily make the time series chart. So mainly in this time we focus the NDVI time series chart, but you can, according to the procedure, you can make the any time series chart for NDVI, NDWI, or other parameter. You can easily make the time series chart. Then we also try to discuss about the export any shape file from the Google Earth Engine platform. It can be river shape file, it can be any region you want to need a boundary, then you can easily make the shape file and export the shape file. And this is a totally geo reference shape file. And then we also try to discuss about that how you can easily calculating the any indices from the satellite images. Suppose you can take the Landsat image and you want to calculate the NDVI, you take the Sentinel image and you want to calculate the NDWI. So we also try to complete all of this part, how you can easily calculating the any indices from the satellite images. Okay, so first of all, Earth Engine public data catalog. So mainly Earth Engine has a vast public data catalog. It consists of Landsat, Sentinel, MODIS, train, land cover, atmospheric data, and more. And it updating daily. This data set will be updating daily, and we can get the update data from the daily update data. We can easily get from the Earth Engine public data catalog. And here we can found the more than 200 public data set, more than 4,000 new images every day. We can get access the more than 5 million images, as well as we also get the 5 petabytes of data. And this is the link for the Earth Engine data catalog. So you can simply go to this link, then you can easily find out the Earth Engine public data catalog or dataset public data catalog, or you can simply go to your code editor and then simply click on the browse data catalog. So you can simply go to this. I simply open my code editor. Wait a minute. So I simply open a code editor. Okay, you can see the search bar. So I want to simply click on the browse data catalog. So when I simply
Mm.
click to here, then this link will be appeared, and it can be show all of the data set of Earth Engine platform, Earth Engine public data catalog. From this Earth Engine public data catalog, I can get access the Landsat, MODIS, Sentinel, any data set I want to easily access from here. Okay, so here you can see this is the climate and weather data. This is the surface temperature data, then climate data, then atmospheric weather, different types of
Mm.
imagery, different types of modis product. Okay, so train, land cover. Okay, recently this dynamic land cover that also added in Google Earth Engine platform. Okay, so this dataset will be recently added and it updating daily. This dataset will be updating daily, and we can easily find out all of that dataset, the updating dataset in here. So this is the land cover dataset, and this is the dynamic world to global products of as the ESA world cover. Okay, so we can get the dataset dynamic recent land cover dataset from this dataset. And this is a dynamic world land cover classification. Okay, so here you can see this is the cropland classification dataset. Other geophysical data we can easily access from here. In this time you can see there are a lot of data set, and now we want to work with all of the data set and import our code editor and work with this data set. Okay, so in this time
Mm.
I will try to discuss about that. I simply go to my slide. So in this time I want to show you that how you can easily import the data set in your code editor. Okay, then how to filter this data set according to your date, according to your time period. Okay, then how to reduce this image collection. Okay, so mainly when you want to reduce the image collection, we want to apply here the mean, median or mode method for reducing this image collection. And then how you can easily clip on your own shape file, and how to display the result on the map. Okay, and how to reprojected the scale pixel value. So in this time I will try to show you this all of the things, so that is practically, so that you can easily understand how you can easily import dataset, filter, reduce and clip and display the data and reprojected the scale pixel value. Okay, so I simply open my code editor. Suppose here in this time, here you can get the lot of data set. In this time I want to randomly select a data set from the modis, so I simply click on the modis. So here I can get the all of the modis product. You can see this is the modis daily products. So this is the daily products. This data set will be updating the daily. Here you can see different types of modis daily product is available in Google Earth Engine platform. In this time, suppose I want to work with the dataset modis vegetation indices, 16 to 200 global to a 250-meter resolution. Okay, I want to work with this dataset. Okay, so when you want to work any dataset, you can simply click to here. You can see when you click to here, you can get all of the information about this dataset. So here you can see the dataset availability date. So mainly this dataset available from the year of 2000, 18 February from 2000. 25 May. Okay, we can access between this time period, we can
Mm.
access the data. Also you can see this is the dataset provider, what is the source of the dataset. And also you can say
I see.
artisan snippet. Artisan snippet is the unique ID. So this is the unique ID, and you can easily get the full collection, the whole collection of this data set is stored in this image collection, this unique ID. Okay, also you can see this is the description of this data set, all of the band, what is the band in this dataset. This dataset resolution you can see 250-meter resolution. Also you can see this dataset provide you with the two band. First band, also you can see NDVI, second band is the EVI. Also you can see this is the scale of this data set. Okay, and you can see NDVI. What is the NDVI? This is the normalized difference vegetation index. So mainly this NDVI is identify the vegetation in a particular region. Okay, also you can see the EVI. So this is the enhanced vegetation index. So in this time I want to work with this data set. So first of all you need to import this data set in your code editor. So you can simply copy, this is the unique ID, so you can simply copy this unique ID and just paste in your code editor. Okay, so after this I simply, you can see, so I can simply put
Mm.
this code editor unique ID, I simply paste in my code editor. In this time you need to just give a variable name, and we already know about the variable name. When you want to define the variable name, you want to just make a keyword. This keyword is the var keyword. You can simply put the var keyword,
Mm.
and you can put any variable name. Suppose I simply put the variable name is the modis. Okay, so in this time this is my full collection. Okay, so this is my full collection of the modis NDVI vegetation in indices, 250-meter resolution. Okay, so this data set is stored in a variable. This variable name is the modis. Okay, so in this time you can see this data set is imported in my code editor. So this is the one way for import the data set in the code editor. Another way is that you can simply search here. Suppose I simply search at the modis NDVI. I simply search. So here you can see, here it also showing the all of the product of the modis, and this is the same which I want to access from the Earth Engine public data catalog website. This is the same. Here you can see I want to work with this data set. Trap vegetation index is 60-day global 250 meter. This is same. I simply click here. I can get the same information of the bands, all of the things. So you can, if you want, you can simply click on the import. This data set will be imported. You can see this data set will be imported. In this time, this default variable name is the image collection. Okay, so in this time it also imported. So when you want to import the data set in your code editor, you can apply the any one method. You can see, if you want, you can simply copy this artisan snippet from here and then simply paste in here, and then you can simply give a variable name. Or if you want, you can simply search the data set in the top of the code editor in the search bar, and then you can simply find out the data and then simply click to the import. Then this data set is imported in your code editor. Okay, and here you can see default variable is the image collection. You can use any variable name, it's totally depend on you. Suppose I simply use here the modis. Okay, so this is the two way when you want to import the data set in Google Earth Engine platform. You want to follow anyone, no problem. Okay, so in this time I want to follow the first way. So I simply give the variable modis. So in this time here you can see this data set is imported to our code editor. So I simply change the name, variable name modis. Okay, in this time you can see this data set has a two product. This data set has a two band. You can see this is the NDVI and EVI. In this time I want to work with the NDVI. Okay, I want to work with the NDVI. So for this you need to select your band. Okay, so you can see my two band, my full image collection is stored this variable modis. From the modis variable I want to select only for the one band NDVI. Okay, so for this I simply take a variable. You can take any variable name. So I simply put the variable name is the, suppose modis NDVI. Okay, you can use any variable name. In this tab you can see this modis, this variable is stored the total two band. Okay, this variable is stored my image, whole image collection. It means that this variable is stored my total two bands. From this two band I want to select only for the one band NDVI. So I simply call the modis because it stored the two band. Okay, whole image collection. So whole image has a two band. Okay, so I simply call the modis variable, so and paste here. Okay, in this time I want to use here the select function. Select. Okay, what I want to select, I want to select from here the NDVI. So you can see what is my band name. Band name is the NDVI. Okay, so I simply select my NDVI. So from the modis I want to select only for the NDVI band, because this modis stored my whole image collection. Stored my whole image collection, and this image collection has the two band NDVI and EVI. I want to work with the NDVI, so that's why I simply select the NDVI. Okay, so in this time this modis NDVI, this what is the variable stored? This variable stored the modis image collection. From the modis image collection it select the NDVI band. Okay, so in this time my final, from the two code, my final variable is the modis NDVI. Okay, in this time I want to check how many images will be available for the whole world between the time period year of 2000 to the present time. How many images is available between this time period for the NDVI? Okay, I want to check it. I simply use here the print function. Print, and then I want to print this modis NDVI. I simply copy this modis NDVI because this is my final variable. I simply copy and paste here, and then I simply use here the size function. So size is a function. It's determined how many images is available in a particular variable. I want to check it. I simply click to the run. Here you can see it will be running. So here I can get total 503 images. 503 images. And what is the range of the images? This range is that you can see time duration year of 2000 to 2022 present time. This time period is, we can find out the 503 images. In this time you don't need to the full range. Suppose you want to need for the only for the 1 year NDVI condition, you want to monitor the any 1 month, or you want to monitor the any 2 year or any 5 year. Okay, so you can select your time period for your own favorable. Okay, so in this time I want to select my own time period. Suppose I want to need the NDVI data for the 5 years from year of 2015 to 2020. Between this 5 year, I want to take the NDVI data. So I want to need that NDVI data. Suppose year of 2015 to 2020. Okay, in this time I want to filter my specific time period. Okay, suppose I want to need this data between this time period. Okay, so for this I simply take a variable and give the variable name is the filter NDVI. You can use any variable name, it's totally depend on you. In this tab you can see what is my final NDVI. You can see this is my final NDVI, because you can see this final NDVI included the 503 images. In this time from the 503 images I want to need only for those images which image is straight between the time period year of 2015 to 2020. So I simply call this variable what is NDVI, simply call and then paste here. In this time I want to simply use a function. This function is the filter sorry, this is the filter date. Okay, you can see what is the argument, start date and end date. You can simply put your start date. Suppose you want to need only for the year of 2050, then you can simply put here the year of 2050 1st January, from the year of 2050 31 December, so that it cover the 1 year NDVI condition. In this time I want to need the total 5 year, so I simply use here the 2015. Suppose 1st January. Okay, and I also put here the in date it be, suppose I can simply put here the year of 2020, suppose December 31. Okay, in this time I want to check how many images is available between this time period. So you can see first time when I want to get the image 503 images, this image is the available between this time period. Okay, year of 2000 to 2022. In this time I want to check here the year of 2050 2022. I want to check how many images is available. I simply use here the print function and then simply call the filter NDVI and then paste here and use here the same function. This function is the size function. Okay, and when I click to the run,
next bracket.
yeah, so here I can get the total image. You can see 138 images is available between this time period. Okay, in this time here I can get total 138 images, and you can see what is the image specific time period you want to check it, when this image is the captured or other things. So I simply check it all of the image information. I simply use here the print and then I simply call the filter NDVI. Okay, and in this time I simply paste here and then click to the run. So here I can get all of the information. Here you can see, so you can see feature. You can see first image is taken the time year of 2015 1st January, then second image is you can see 17 January, then 2nd February. Every image has the total interval time period is the 16 day. So this data set, so that's this data set called the 16-day global 250 meter resolution, because I can get the every image interval date is the 16 day. You can see every image interval day is the 16 day. Okay, so that's why this data set called the 16-day global. If you want to need the data set for the annual, suppose every 1 year NDVI data you want to need, then you need to work with the annual data set. You can simply search here the annual NDVI dataset, then you can get the annual NDVI dataset. And this is a totally same process for filtering all of the things which I want to show in this time. So if you want to need the monthly NDVI time series or 32-day global 250 meter resolution dataset, then you can get all of the dataset for the vegetation. If you want to need the dataset for the Landsat NDVI, then you can simply search here the Landsat NDVI data, then you can get all of the Landsat data. Suppose Landsat monthly dataset, you can get the Landsat 8-day composite, you can get the Landsat 32-day composite, you can also get the Landsat annual composite. So all of the dataset we can easily access from the Google Earth Earth Engine platform, and we can easily processing all of the data set according to the same process. In this time I want to work with this 16-day global, so you can also try to do it for the year annual data set. You want to try to the Landsat 8-day composite data set, then you can get the every 8-day images, okay, interval images you can get. In this time I want to reduce this image collection. Here you can see this is a lot of image collection, there's a 138 images, and this image is not captured at the same time. It will be you can see this is the different time period, okay, 16-day different time period. So in this time when I want to make the all of the image make the NDVI map, then it will be overlaying to each other, so it will be overlaying to each other. So for this region, in this time I want to reduce this image collection, so that's why I ignored the overlaying all of the images, okay. So how I can reduce? So mainly we can use the reduce for using the mean or average NDVI. From this you can see 138 images. I want to use here the average reducer or mean reducer to our data, which reduces the image collection by calculating the average of all pixel values at each pixel across stack of all basic band. Okay, all of the basic band stack in here. So in this time I want to reduce this image collection. So for this I simply take a variable. Suppose I simply give the variable name is that, you can use any name, so I can simply put here the mean NDVI, or the 138 images is stored at the filter NDVI. I simply call the filter NDVI and then paste here. After that I simply use here the reduce function. In this time I want to reduce this image collection. I use here the reduce, and I want to use here the Earth Engine reducer mean, okay, average. I want to get the average data, so I use the reducer mean. In this time I want to show this average result in my map, so I simply use here the map dot add layer, okay, and then I simply call my final object mean NDVI and simply paste here and then click to the run. So now you can see this map showing a whole over the world for the NDVI result, okay. So in this time it will be showing, but this map is not good because I did not add any visualization parameter. So in this time I want to add here the visualization parameter. So they are already provide some visualization code, you can see. So I simply copy this visualization code from here. So I simply copy this code from here and then I simply paste here. In this time here you can see they make a dictionary. So they are make a dictionary. In this dictionary they are put a mean pixel value, it will be start from the 0, and max pixel value up to the 8000, and they are also use here the different types of color plated, okay. So this is my visualization variable. You can see I simply copy the visualization parameter variable name from here, and we already know about that. After the object name we always put here the visualization parameter. So I simply put here the visual parameter variable. You can see I simply paste here, and then I simply click to the run. So now you can see what happened. I want to simply click run. We can get the whole world NDVI map for the whole world. So from this whole world we can easily identify where the vegetation is the dense and where the vegetation is the low, okay. So here you can see this is the dense vegetation region, okay. Also you can see this is the desert region, okay. So this is the desert region, okay. Also you can see, so there you can see, also you can see some vegetation also here, also you can see, okay. So also you can see this is the Iceland, there is the so much less vegetation area, okay. So you can see this is the Latin America, so this is the huge vegetation in this for the Amazon, okay. So we can easily identify the dense vegetation area and low vegetation area from this code. And in this time we this data display our data on the map. We can see how fast it works. We have calculated the mean or average of all images between the year of 2015 to 2020 within a second. We can calculate it. So this is the fast calculating power of Google Earth Engine platform, okay. So in this time, suppose you don't need to the whole world NDVI map. You want need for your only for your own country. Suppose you need the India, Bangladesh, or any region. Suppose you want to create a shape file. You want to need the NDVI map for your region. So it's also very easy. So for this, you can simply import your shape file.
Mm.
So you already know about the import the shape file. So from the asset tab, you can simply use here the your import your shape file and work with this. Okay. Or if you want, you can simply use here the suppose US DOS dataset for taking the
Mhm.
country level boundary shape file. So I simply
Mm.
import this dataset in here, and you can see it is a default variable and table. So in this time, I just filtered this table and get my specific country boundary shape file. I simply take a variable and give the variable name is the suppose country. Okay.
Mm.
In this tab you can see this table stored my whole country boundary shape file in the world. From the table I want to filter my own country, so I simply call my table. Okay, then I use here the filter, and we already covered this part when I want the first class. Use here the earth engine filter dot equal. Okay, and what's equal
Mm.
what, I simply use here the country suppose name, and suppose I simply put here the country name is that suppose Bangladesh. And now you can see now this country variable, this variable is stored my shape file is Bangladesh. Okay, so now it will store it. So in this time here you can see the mean NDVI. Okay, so this mean NDVI is represented for the whole world. From the whole world I want to clip my own area, or my own country boundary shape file. Okay, so for this I simply take a variable and give the variable name is the study area. You can use any name. I simply use the study area, and in this tab you can see the mean NDVI. This variable showing the whole world NDVI map. From the whole world NDVI map, I want to clip my region or my geometry. So in this time, my geometry is the Bangladesh shape file, and this Bangladesh shape file is stored the variable country. I simply call the country, just copy and paste. Okay, I just paste here in. Okay, so this is the country. Okay, so it's not copied. I simply copy and then simply paste here. Okay, in this time you can see my final object is the study area, because I want to show this NDVI map for my country. So I simply copy and paste here. In this time,
Mhm.
when I click to the run, you can see it will be showing a layer,
Okay.
but it's not focusing my shape file, it's not focusing my area. Okay, so in this time for the focusing the center of this shape file, I simply use a function, it's the map center
Mhm.
object. Okay, and I want to focusing the shape file. My shape file is the country, and I want to focusing the zoom level suppose 10. Then click to the run. So now you can see it also focusing my country boundary shape file, as well as also provide me the uh, NDVI map of Bangladesh from the year of 2015 to 2020. You can see. And now if you want, you can easily export the map, and finally you can easily import this TIFF file in ArcMap software and easily make the map layout. Suppose I also try to share the some map which I already created from here. So where is it? Just a minute. So I will give the example. You can see this is the map. So mainly this is the land cover classification map. But this
Mhm.
land cover classification map I created in Google Earth Engine platform. I created this map in Google Earth Engine platform, and then I simply download the tip image. Suppose you can see, I simply download the tip image and import the tip image in my ArcMap software. Then I simply create the legend, all of the title, scale. I can easily add here. So this is the same process. When you want to work with the NDVI map, you want to need the NDVI map, you can simply download the tip images and you can easily make the map layout or other things easily make in your ArcMap software. So wait a minute. So okay, so you can see this is the another map for the Colombia. This is the NDVI map of Colombia. So mainly in this time, I just make the NDVI tip image like this. You can see which I created in this time, like this image created in here. Then I simply import this map in ArcMaps as a tip format. After this tip image, I want to simply import my ArcMap software, and then I simply make the, you can see, map title, map scale, then map not line, then legend. Okay, all of the things I want to add here. Okay, so in this time here you can see I simply use here this map for making the Google Earth Engine platform, and then I simply make the map like this for use my research paper work or my presentation work. You can easily do this. So I also try to show you the process how you can easily export the map and make the map layout or other things in ArcMap software, so that you can easily understand. Okay, in this time here you can see I easily get the Bangladesh. Suppose you want to read the for the another country. Suppose you want to read for the India. You can simply press here the India and then click to the run. Now it will be showing the NDVI map of India between this time period. So here you can see we can easily get all of the NDVI map for the world. So just you can put your country name, because you can see this dataset provide all of the country boundary shapefile. I simply provide the country name, suppose Pakistan, and then click to the run. So in this time, here you can see I can get the result for the NDVI map of Pakistan. Suppose you want to need for the another, suppose you want to need for the Australia, you can simply use here the Australia. You can get the map for the Australia. So here you can see you can get the map for the Australia. So now if you can easily make the any, suppose you want to need for the map for the Latin America or Africa region, then you can simply, because this dataset also provide you the Africa region shape file, or South America, Latin America, Europe, all of the all of the continent or region, you can easily get this shape file. Suppose I want to need for the map for the another, so I can simply try to show you that. Suppose you can see I simply use here the world region. So I simply call the world region. Okay, then I simply paste here the world region. Suppose I want to need for the Africa. I simply use here the Africa and then click to the run. So now you can see it will be provide you the Africa, whole Africa region NDVI condition. Okay, we can easily get. We can get only for the Africa region NDVI map. You can see this is the Africa region NDVI map. We can access the Africa region. You want to need the South America or Latin America, anything you can easily access from the this shapefile, because this shapefile provide you all of the country boundary shapefile. And this is the same process. This is the same process, but in this time, this it has a problem. When you want to search the what is the NDVI value range, you can see NDVI value range. I simply search an NDVI value range. So here you can see mainly NDVI value range from +1 to -1. Okay, so and +1 is this pixel value. I identify the vegetation, and -1 negative, this negative value identify there is the no vegetation. It can be water or it can be build up area or other, but there is the no vegetation. When I can get the pixel value for the negative, it's identify there is the no vegetation, and when I can get the value for the positive, it identify their vegetation. When I can get the value for the closer to the 1, suppose 0 0.9, 0 0.8, 0.7, like this value, when I can get, it's identify there is the dense vegetation. Okay, in this time when I want to see this map, you can see I want to, suppose I want to check the value. So I simply click on the inspector tab and click on this any portion of the map. You can see what's the value I can get. I can get the value like this, 7704. But we can see that what is the NDVI value range. You can see -1 to +1, but it's limited. It's, you can see it does not maintain our limit +1 to -1. It's showing the 7704 like this value. Okay, in this time I want to reproject this scale value. So
Okay.
when you want to reproject the scale value, here you can see they are already provide a scale. Okay, you can see they are already provide a scale. In this time I just use this scale value, and then I want to reproject this scale factor, and then I can easily get the result from the -1 to +1. This range I want to get the value. Okay, in this time it has a global data set, so that's why globally they are use this mean, you can see, and max this value. Okay, but they are also provide a scale. When you want to work with the local region or your own region, then you can simply multiply this scale with your image collection, then it will be automatically reprojected. So that's why they are provide a scale. And this scale is not suppose when you want to work with the any data set, suppose when you want to work with the modis land surface temperature dataset, we also covered this part our future class. But when you want to work with the modis land surface temperature dataset, here you can find also a scale 0.2. So this scale factor is the 0.2. Just you can multiply this 0.2 with your whole image collection, then it will be automatically result your local region, not global. Okay, in this time I want to need the data for my local region, not for the globally. This data, you can see which value I want to get from the 4500. This data is correct, this value is the correct for the globally. But when you want to work with your own region, then we need to maintain the value 0.1 to -1 to +1. So that's why they are also provided the scale. So that's why we need to use the scale. Using this scale we can easily uh, uh, reproject it our scale factor. Okay, so in this time I also try to show you that. So for this, when you want to reproject it the scale factor, we need to just make a function. So in this time I want to make a function, so that this function multiply. Here I can get total image, you can see 138 images, so I can get all of the images, you can see 138 images. So in this time every image, suppose you can say first image, this first image I want to multiply 0.001. Okay, what is the factor? I just multiply. I also need to the second image, I would also need to the third image. All of the image, total 138 images, all of the image I want to multiply with 0.001. What is my scale factor? I want to multiply. In this time here you can see there are the lot of images, 138 images. If when you want to go to the traditional way for multiply with your scale factor, it's a long time you need. But when you want to use a function, it reuse your code and make it easier. Okay, so that's why we want to make a function. So that's why this
Mhm.
function multiply all of the images with our scale factor at the same time. Okay, so
Okay.
we don't need to differentiate from the, suppose first image you want to multiply, second image multiply, not like this. So we want to create a function. This function multiply with my scale factor all of the images at the same time. Okay, so it's reduced my time. So that's why we need to create a function. So I simply create a function in here, suppose. So I simply create a function. So when you want to create a function, you can simply put a variable name. Suppose I can simply put the variable name is the suppose scaled NDVI. You can put any name. So in this time, okay, so in this time we can see a scale NDVI. This is my function variable name. Then we need to use here the function keyword, and then we need to put here the element name. We already know about the element name. Suppose in this time you can see element name is that in this time I want to suppose this 138 images, all of the images I store a variable. Suppose this variable name is the image. Okay, so I simply take the element name. So all of the image 138 images in this time I just, you can just remember that this 138 images is stored this image, this element. Okay, this is my element. In this time when I want to just multiply with my scale factor with this image, then it will be all of the image will be completed for the multiplication with my scale factor. In this time I simply use here the curly bracket. In this curly bracket I simply use here the return function. I want to return from what I want to return. So that's why it will be multiply with my all of the image, multiply with my scale factor. What is the scale factor? You can see.
0.001.
So this is our scale factor. I simply copy from here and that paste. So in this time what happened, you can see in this time this is my image. I just remembered that this image is stored my all of the 138 images. So I simply multiply this image with my scale factor in this time. In this time we need to also take another function. This function is the copy properties. Okay, in this time I want to multiply all of the images. So that's why this value, this scale factor is multiply with all of the images. Okay, so that's why we need to use the function. This function is the copy properties. So that's why this properties is copied, or this which property I want to multiply, it will be copied from for all of the images, so I simply use here the copy properties. Sorry, copy properties. Okay, so copy properties. So what is the copy properties? I want to copy properties this image. Okay, and then it will be start from the system time start, and also system time in. What is the meaning? You can see it means that in this time I want to just this image is stored my all of the images 138 images, and I want to just multiply with my scale factor, and then I use the copy properties. So that's why these properties, which property I want to multiply, these properties will be added all of the images. Which image is the state the system time start, it means that which image is the state in this time start, and system you can see time in. So in this time here I can see this time period we can get the 138 images. So that's why I need to multiply, or copy properties is just copies these properties. So this copy properties also you can see, suppose you can see this is the first image. I want to just multiply. When I want to use the copy properties function, it also multiply with this vector. When I want to use the copy properties function, it also multiply with this images with my scale factor. And so that's why I simply use here the system time start. You can see this system time start means that I already defined a system time start and system time end. Okay, so I want to multiply all of the images which image is the state between this time period. Okay, so that's why I simply use the system time start and system time end. Okay, so in this time here you can see I simply use here this part. Okay, so this is the function I created, this function. In this time I want to add this function with my collection. What is my collection? You can see this collection is the filter NDVI.
Yeah, filter
So
NDVI.
this filter NDVI stored the total 138 images. Okay, in this time, this 138 images, I want to represented this scale factor. So that's why I simply copy the variable name and then simply paste here. Okay, you can see this is my full collection and this is my function which multiply with my scale factor. This is my full collection and this is my function. I want to add the both two things with together. When you want to add the two things with the together, we need to use a function. This function called the map function. I simply use here the map function. Okay, then simply use here the parenthesis and also put here the last parenthesis in here, just in here. Okay, so here you can see this is my function and I want to add this function with my whole collection 138 images. So now it will be automatically showing the images, the 138 images, and now this image will be reprojected, and the reprojected scale value is stored this variable scale NDVI. I want to check how many images is available for the scale NDVI. I simply print
Print
and
NDVI.
then call the scale NDVI
Scaled.
and paste here, and then use here the size function and check
Mm.
how many images we can get the same image. You can see because
138.
we use here the system time start and system time end, because which system
Oh,
I want to set here, it will be showing the same image. We can get, okay, we can get the same images. in this
yeah,
time
138.
in this time we want to use this scale and DVI. All of the things we want to use here the scale and DVI, and then we want to easily make the reprojected scale factor. So in this time, if you have any question in this code, you can ask me any question in it out.
Okay, let's see. So when you build in the code, the first thing you need to do is when you start the code, you get the image
Yeah,
from the image collection,
yeah,
right? And then you get the boundary layers or the shapefile,
yeah,
right?
yeah,
And then after that, then you do the filter.
yeah,
And then when you run the filter, then on the filter you do the function file.
yeah.
And then from the function file, then you put it onto a
Reprojected.
map,
Yeah.
right? Reproject it. So when you're doing the reprojection, can you go down on the codes, please?
So here you can
On
see,
your console.
yeah, when you want to
Yeah,
reproject this scale factor, you need to
yeah.
multiply. You need to multiply the scale value. They are also already provide the
Mm,
scale value. In this time, this scale value I want to multiply with my whole collection, the filter NDVI. And this filter NDVI have
mm.
the total 138 images. So individually,
Right.
when you want to multiply one by one images, so it's take a long time. So that's why I create a function like this. I create a function. So in this function, I
Yeah.
simply use here the image. So this image, you can just remember that this image is the stored total 138 images. So that's why I simply use the image and multiply with my scale factor. And
Mm,
these properties, I want to separate all of the rest of the images. Suppose all of the 138 images. So that's why I simply use here the copy properties, and these properties I simply use here the image and define here the system time start and system time end. So that's why all of the image is multiplied with my scale factor between this time period. Okay, I can
and
get the total
then
38
just-
images. It will multiply with the total 138 images. Yeah,
yeah. And then you just use the reducer for the mean,
yeah.
right? So on that you do the reducer for the mean. When you do the reducer for the mean, but you see, you need to in that code now where you pull in the function code for you to filter the NDVI because you don't have that
In
before.
this time, we just simply copy this variable scale and DVI. Simply copy
Mm-hmm.
and then simply paste here. Okay. So now I want to
Mm-hmm.
reduce my this 138 images which I reprojected. So scale and
Mm-hmm.
DVI, I simply use here the reprojected. Then I use here the mean. Okay.
Yeah.
Okay. So any question you
Then
can
you
see?
put,
Okay. In this time when I
and
run,
then
yeah.
yeah, and then here when you do that, you need to get, you see that var NDVIS. You need to pull that from the other one, and then
Yeah.
you clip it off to
Yeah. Yeah.
the ending.
In this time when I run this code, you can see what happened. I can get totally white color map because you can see Okay, you can see I can get the total white color map. In this time here you can see I want to create this reprojected scale factor so that I can get the result between -1 to +1. But you can see what
Mhm.
is the you can see point and 8,000. So I simply change it. Suppose point
To
1
-1,
-1 to
then this one.
+1. Yeah. So that why I can
Yeah.
get the map for the, you can see. Okay,
Okay.
and you can see it will be showing the color, and this there are the lot of colors. Suppose I want to use some color, I want to use here my own choice. So I simply use here the color. Suppose I want to show which pixel value is the -1. I want to show the pixel value as a, suppose, blue color.
Okay.
Okay,
No
I want to
problem.
show the greater than -1, but less than +1. I want to show the, this is the white, and I want to show which pixel value is the 1 or closer to the 1, it will be showing the green. So it identifies the dense vegetation, and then click to the run. So now you can see I can get the result according to this color, and you can use the any color, no problem. And when you want to easily export this map, and you can easily use any color.
Okay, that's for Africa.
Okay, so you can see. So you can see this is the desert region. Also you can see this is the vegetation. Also you can see now you can easily
Yeah.
separate the region where the vegetation is the dense or where the vegetation is the low. In this time I
Mm.
want to check the value. Suppose I simply click on the inspector tab and click on this here. You can see what the value I can get. I can get here the 0.7, and this is the maintain the change between the +1 to -1. Okay, so
Mm.
now it will be reprojected.
So the correct one, because NDVI is an index from -1 to
Yeah,
+1.
yeah, so that's why I can get the result according to my uh, range between the -1 to +1. So now you can easily export this map, and you can easily make the map layout or other things like this. Here you can see like this. You can see it's also showing the on point of -0.19 from the
Mm.
0.92. Okay, so we can also easily export this map and easily make this map layout or other things easily. In this time